over 18 patents, and over 16 RFCs. And on a personal note, I'm going to say I've been working with him for 3 years on the IIESoc, and I tell you something, any project he is on is one you want to work with. Extremely detail-oriented. If you want something to get done, this is your man. I'm just telling you something. I'm just so thankful to be working with him. So Dhruv, let me turn it over to you.
Hi everyone, thank you for the kind words. And let's start. So more or less Nalini covers where I'm coming from. Apart from the chairing thing, we also have a routing directorate where we review all the routing documents across the IETF. So I'm a member for that. I'm recently an IETF Sergeant at Arms, where we need to make sure that the mailing list discussions are going smoothly and there are no fireworks. So that's another new role that I've taken. My first IETF meeting was in IETF 78 in Maastricht. Just before I met Adrian, we went to Ipswich, where we were discussing one extension in PCE, which I'll talk about a little bit, and that's where the journey kind of started. And also, so my journey in IETF is kind of the journey of how the PCE working group is kind of involved, so I'll be kind of covering that. And also with IIESoc, I'm doing the secretary role there as well, and you can find more information on my webpage as well. So this Adrian covered very well. He talked about what really is traffic engineering, and PCE plays a very key role in the whole process of traffic engineering. So traffic engineering is basically when we go beyond reachability, and it's not just whether A and B can connect with each other, but what is the properties and the characteristics of the path that you will take while packets from A move towards packets to B. And why we do it, I think after network slicing talk, I think it's pretty clear that there is a clear demand for traffic engineering, and it's been there for a while. It's not something new, and PCE has always played a key role. And why is that? So I'll cover a little bit of history and then focus more on the new things that are happening in the PCE working group. I'll skip this slide because Adrian covered this quite well. Let's take this as a analogy that maybe even Fred brought up. Like, you need to go from point A to point B. In this case, let's use the Kolkata airport and our Eco Hub venue. Those are our endpoints, which is the requirement for any path computation. You need to figure out what are the two endpoints that needs to connect with each other. Then you talk about constraints. That is, what kind of path are you looking at? Do you want to reduce delay? I don't have any money. I don't want to pay any tolls. So maybe avoid all the tolls. So these are the constraints that you want to put over the path. And then there is somebody who's going to do the path computation. That's the PCE in our case. And the resulting things are a set of paths that are available, in which case in the map, as you can see, there's one of the paths highlighted. The traffic engineering database, which Adrian was also talking about, is basically a map. This point connects on this link, which is a road. This road has this capacity. Some roads are small, some roads are big, some roads have tolls. That's nothing but your nodes and links in any of the network. And the PCE is basically the Google Maps who is helping you compute the best path from reaching from point A to point B. So this is the definition. The definition states that it's an entity. Again, by entity it means that it's not a particular device, it's not a server, it's just an entity. And you can place this entity wherever you want in your network. Right on the node, right on a dedicated server, part of your NMS system, anywhere. It's just an entity which can compute complex network paths based on the computational constraints as applied. That's nothing but what the PCE does. So what are the basics in PCE? You have the guy who's doing the computation and the guy who's asking for the computation, which is the client. So the client asks, give me the path from this to this, and these are my properties of the path. That's basically your PCC and PCE. And the language that they are using to communicate with each other, the protocol, that's the PCEP protocol. So this work started in around 2004, so it's pretty old. It's been there for a while. Our first RFCs was in 2006, which was about PCE architecture, that's 4655. And since then we have published 45 RFCs, enhancing PCE in multiple ways, and that's something that we'll be covering in the rest of the talk. So the first thing was, why do we need a PCE to control, to compute the path? Why can't the source node itself find this thing? So why can't the guy who needs to go from point A to point B, let the A decides how he wants to do this thing? The problem is that A might have a limited visibility in the network. He's just a node, he might know things which are happening right across. Same, let's take the Google Map example as well. You can make a decision of which road to pick at a particular junction, but you don't have a full visibility of what's happening 3 junctions down. And where there is a traffic jam or where there's a link, you rely on a Google Map. You go to a central server, ask him, from A to B, where you have a better visibility, tell me what path I can take, and that's the path I will follow. So the same reason, even in the network, instead of the node making a decision, we wanted to offload that to a PCE who has better visibility. Now, why would he have better visibility? He can, as a central entity, he can cooperate with other people, like find out what's happening in my neighboring domain. Maybe I have some enhanced capability like telemetry. These days, telemetry is a hot topic, and I have not just the information which is nodes and links, but I have real-time what's happening. Same thing with Google Maps. You have, I know, given this road, what is the capacity of this road, but what's happening at this exact moment via good sensors and telemetry, I can have a much more enhanced traffic engineering database, and that's where I can apply it at the PCE and make much better decisions. So, and also we wanted to have a capability of, like, when you have central control and an SDN, the programmatic part comes in. That for some guy I want least delay, for some guy I want jitter is important, some guy needs more bandwidth, and I want to run not just constraints, but different types of optimization functions and different algorithms to figure out what's the best path is, and doing it at a central and coming up with a much more better algorithms at a central location gives me that advantage. So that's the brief history of why we started with this work. The work, like any IETF work, went through multiple cycles. The first thing was, let's write down the architecture. Then comes the basic protocol, given a PCC and PCE. How do we know that the session is alive? How do we send an open message, keep alive, close a session? What are the basics of my FSM that I will run in this protocol? That's what you have to, that's your base. That's what RFC 5440, the basic of how the protocol is supposed to run. Then came the good use cases of those protocol, and one of the key use case was inter-domain. That especially in a network, I have a less visibility of what's happening in the next domain. A PC can work with each other, cooperate with each other to get a better visibility and help me compute a better path. So that's the inter-domain path computation mechanism. That was VRPC. Moment you do inter-domain, the confidentiality comes into play. Oh, I don't want to expose things that I don't want to. So within the cooperation mechanism, you need to come up with a way, how do I hide information? That was our next work, which was path key. New types of constraints, like when I'm looking at, say, diverse path computation, I just don't want the best path. I want to make sure I don't go to these links. And the path that I'm going to use maybe as my primary path, I want to completely avoid when I'm using it as a backup, so that I don't have the same fate sharing with the same links that can go down. So those kind of things comes into the exclusion part. Objective functions, we talked about minimum delay, jitter, bandwidth. What are my ways, what am I trying to optimize? And there are multiple ways to represent that in the protocol. That's what we call as an objective function. So far we focused on unicast, go to point A to point B, but this works for multicast as well, where I'm maybe broadcasting things, or where one source and I need to make sure that every endpoint is receiving this information. That's the P2MP multicast. So path computation can also be used to compute a P2MP tree, and that's where the PCEP can also play a role. And in fact, a PC can play a much better role, because these computations are much more complex than a unicast path computation. The tree computations are more complex. Putting that, offloading that from the head node to a guy who specializes in this is much better. So that's where we use the P2MP. And in fact, my journey in this working group kind of started with doing the P2MP work. So that's the place where I started contributing to the IETF. Then we moved on to hierarchy. I think in Adrian talk, we talked about, oh, these controllers, there are customer controller, MDSC, the network controller. What's that? That's just a hierarchy. And all of them are path computation element in their own way, because each of them has an ability to compute path within their domain. A down physical network will compute path there. There's a virtual network, the abstract network that you have got up higher. Still in that network you need to do path computation, because there also you have nodes and links and the properties. The ability to compute path doesn't change, the function doesn't change. It's just the topology is different. You have a very detailed topology down there, but as you moved up, you have a different abstraction. And that's where the PCE, how does the different PCs at different layers can interact with each other and help you compute end-to-end path. That's what was our next work. And of course, this technology is not just for packet, not just for MPLS. In fact, our killer application has been the optical network. And the adoption that we have seen for this in optical is much, much higher, where you have path computation for GMPLS, for WSON, for all kind of optical layer networks. Within that networks where you have constraints are much more important. And those constraints and the computations are much more complicated. PCE plays a very, very key role in those networks as well. And finally, interlayer. As we know, we think IT guys kind of sometimes assume that A and B in my OSPF link is usually directly connected. That's how we do our testing when we run our OSPF protocol, and we sometimes are surprised that no, there's not directly connected. There are lots of things happening in the below layer for these 2 points, A and B in 2 cities, to actually connect and act as a one hop away in the IP layer, but down there's lots of things happening. PCE is such a technology that since it can run in multiple layers, this protocol can easily be used in interaction between those layers. So a PCE at a higher IP layer and a PCE in an optical layer can communicate and make sure that the end path's results, the requirements that you have for the interlayer path, meets. Because it's not, if you just look at the constraints at IP layer and ignore what's happening in optical, you might not be able to satisfy what was the real requirement. This thing, and same thing comes from the network slicing kind of thing as well, that you might work at a higher layer, but you need to make sure there's interactions between layers so that what you represent at the top layer is actually being fulfilled in the bottom layer. So this was our initial journey. In fact, we did a lot of work, a lot of these things was the base, and now my presentation is more looking at what's happening next after this base is already established in the PCE working group over the years. We were initially all stateless, and what that means by stateless here is that PCE was an entity. You have to ask him, give me the path, he'll compute at that time what is the best path possible, just replies to you and forgets about it. Like any server, any stateless server, it behaves when there is a request from a client, it does the work, replies it, and forgets that he ever got any request, this thing. It works. For the basic applications that we saw, it worked quite well, but once we moved to more enhanced application, and network slicing being one of them, this is not going to suffice. We need to we have an ability to make changes to the path that we have computed before, and can't just rely on the head node or the PCC to remember, oh, maybe things have changed and I need to get a better path. We want the central controller, the PCE, to have the ability, by looking at the network topology change, looking at the impact of other paths, other slices, to make changes in the network. And that's where we need to move to the stateful PCE. So this was around a few years back, a recent main change that happened in the PCE working group, where we started focusing from stateless to stateful. And we defined what are the different, we defined two types, which is passive and active. Passive is somebody who will maybe just remember. He will remember what all paths are there in the network. So basically, to do that, you have your traffic engineering database, which was nodes and links. And then what are the paths? What are the previous computations that I have done and how they are behaving in the network? That would be your LSPDB. LSP is label switch path, a database where all the paths in your network are also stored. So combination of traffic engineering, network, and paths I can do much more better computations and try to give you better results, especially in the slicing world, where I have to group things in a virtual network and these are related to each other. Not every part is completely behaving on its own. It has deep impact on one another. So where this relationship, the PCE, when it is aware of it, can do better path computations and make better decisions. An active one is not just looking at the database, but also going back to the network and asking him to make change. And in the network slicing use case, that was one of the key things that we saw, that you have traffic engineering learning and then PCE protocol being used to also push the change that we want into the network. And not just making changes, I would have the ability to also initiate the path the first time that I need it. Like an SDN controller, we can just talk to the controller that give me a path from A to B and it will take care. You don't have to talk to the node from the management system. PCE protocol can take care of creating a path for you. So that was also a very key thing in the slicing as well as in the ACTN and those kind of use cases in the PCE. So far, when we started, RSPPT was the only signaling mechanism. That was the way, once we have computed the path, how does every node on the network knows that this is the path that I need to follow, this is the resources that are reserved for it, making sure that the path is active, reporting the status of the path, reporting failures. All of that was done by the signaling protocol called RSPPT, which was going from node to node, and whatever the path that the PCE has computed was responsible for setting up of that path. But last few years, we have also something called as a segment routing. And we have the next talk, which focuses more on the IPv6 enhanced flavor. So we have moved, so there was segment routing, SRMPLS, SRv6, and now we have in IETF working on something called as an SRM6, which I will let Reggie go in detail. But the basic of segment routing is, what if I don't have to do hop by hop signaling and I can put all the states that I need right in the packet itself. So instead of a control plane protocol taking care of establishing that path, PCE computes the path, gives it to the head node makes sure that that path information or how to route that packet in the network, all that information is stored in the packet itself. And if we do that, to enable this, what are the changes that we need to make? Of course, one thing would be that we need to maybe change the way we run our IGP. So we need to have some enhancements to IGP where we will be addressing a particular node and adjacencies. And if you have a way to identify those nodes and adjacency in your packet itself and encode it in the packet, that's good enough. So the IGP extension is basically, let me flood some identifiers. Those identifiers are called sits, node sits, adjacency sits, and then in the PCEP you can make a list of those identifiers, push it onto the packet. In case of SRMPLS, it is pretty straightforward because MPLS already allowed label stacking, and if we consider sits to be labels, just a stack of labels are enough for me to start using SRMPLS. In SRv6, we had to do some more changes, so there is an SR extension header. I would let the next talk about it. But the PCE played a very key role. You still need the path. Maybe you can remove the control plane, but you still need the ability to compute the path, create those label stacks, and that's where the PCE plays a very key role. And in fact, a lot of new work in the PCE working group right now is dealing with the segment routing extensions and enhancement to the PCEP, which I will deal with. So the idea is pretty straightforward. You had paths. Now let me have a new way to represent a segment routed path. That's what we call as SRDRO, and maybe our ability to tell, oh, by the way, I'm going to signal this using SR mechanism. I'm not going to use RSPPT. That's it. And the rest of the protocol already supports everything. It's just how do you identify a path is changed, nothing else. Everything else is pretty good. One more key thing that we did in the Stateful PCE world was associations. A mechanism for set of paths that the PCE is computing, let us group them together and apply some policies, some constraints, some relationship between them so that we can come up with some interesting use cases. If I have an ability to group random things, that's the generic mechanism, I could come up with a lot more use cases. The use cases were protection. Oh, one is a primary path, one is a backup path. Only when the primary fails, the backup is triggered. So you can group who am I protecting and what's my relationship, what kind of protection technique I'm using. All that thing we can put in this grouping. Diversity, node diverse, link diverse, all that stuff. Policy, apply, like especially in case of network slicing, when I have a policy that applies to the whole VN itself and the bunch of paths in that VN, I can group them together and apply policy in a much more simpler way. And that's what the protocol allows. Bidirectionality, virtual network for the ACTN use case, resource sharing. So like this, by having a very generic mechanism, the working group has been able to think of very good use cases of how to use these generic mechanisms and come up with better ways to do path computations as well. In the stateful PC world, the next set of things that we did was, of course, we need to support for multicast and P2MP as well. Auto bandwidth is a very interesting application where we don't want to reserve the bandwidth for the path fixed. We want to see how the traffic is flowing and change it, and of course the PCE can help do that better. Scheduling is something that Adrian and I worked on it, that okay, now you have a controller, what if I'm able to schedule paths, that I need this path during this time and I have an ability to take down that path, create that path, have a cycle, have a way to schedule things. So another layer over the generic, the traffic engineering database and the LSPDB, what if I have a schedule DB as well, where I'm taking care of scheduling. Stateful GMPLS and hierarchy of stateful PCE. Hierarchy of stateful PCE is basically the base on which PCE use in the ACTN is developed. And most of this work is kind of ready. It's there in the RFC editor queue, ready to be published, and some of them are just getting there. So this is what the work that the working group has done so far. Now, I will skip this because I think Adrian covered this part quite well. And I'll focus on one key thing that we did in the last couple of years was we started using PCE more like an SDN controller. So one of the things with the concept here was that what if I'm able to program the nodes across the path, just like maybe let's take an open flow analogy in the similar way. Can PCE protocol help me do that? Can I have a mechanism to send central control instructions to the node, which are more closer to the programmatic instructions? So I'm not just talking to the head node, which was pretty common with the RSVPT and the segment routing. What if I'm able to talk to all the nodes in the network using the PCE protocol and give instructions? Would I have, what kind of enhancement can I have compared to the RSVPT and the segment routing way of doing things by using this PCC control? So this is more of still an experimentation. It's going on. We have the architecture thing published. The extensions are still ongoing. So the concept here is pretty straightforward. You have a generic instruction called CCI, and the PCE will program the nodes and tell if you receive a packet with this particular label, this is the operation that you need to do. So the PCE can take care of the label management part of the network as well and start assigning labels to the to the devices and have much more finer control than what we saw in the RSVPT and the segment routing case. And the same concept can also be used for P2MP, for SR, for SRv6. So a lot of interesting use cases are coming for PCCC as well. There's PCCC for native IP, where not just MPLS, what if it's a native IP packet, how do I instruct from PCE some instructions? That's also is possible. And protection, how to do protection better. All those things, because in earlier work, doing FRR, was you have to rely on talking to PLR or the merge point. These things, since PCCC can talk to all nodes in the network, you have a much better, easier way to come up with these use cases as well. Once you have established the path, there was one interesting thing was, how do I tell which traffic to flow on this particular path, right? And that traffic is basically nothing but what we call as a flow specification. It was first done in BGP, mainly for DDoS, but now it has taken its own thing, and there are a lot more interesting use cases like route policy, etc. But the idea here is not just the path. I should have an ability to also tell what kind of traffic needs to put on this path. So you can identify a particular traffic by addresses, by port numbers, by various different fields that you see right inside the packet, and then assign that traffic flow onto a particular PCE. So we are not replicating everything that's there in the BGP, but the idea was only for the PCEP traffic engineering parts that the PCE is anyway controlling. Can I also assign the traffic engineering, the traffic flows onto that path? So it's not the full replication of what BGP can do. It's very focused on the traffic engineering and the MPLS-TE parts only. One interesting thing that this is something that still the working group is not convinced. It's been discussed a couple of times. The idea being, oh, why do we have so many different protocols doing this thing? What if wouldn't it be simpler if I was just using a single protocol inside my network to do all of this? Like I do something in BGP, something in PCEP, something in YANG, and my implementations become super complex to do that. Some buy into that argument. The IETF is still not convinced. This is an ongoing debate that's happening. But one of the key people also here is the optical folks, and some optical folks like the idea of oh, BGP is IP thing. Why are you asking us to do? We are more happy to use PCEP. PCEP is something that we are comfortable with. What if I can use the same protocol to also learn the link state and the traffic engineering information from the nodes as well? And also in the ACTN cases where we have the controllers who are cooperating with each other, and there is a level of abstraction, maybe PCEP LS can help us, and using this one protocol, can I solve that problem? This is still an ongoing debate. This has not been resolved, but I just wanted to put it out there. For the network slicing in ACTN world, the PCE, the most important part is the stateful HPCE test. The idea here is, if I have a hierarchy of stateful PCE, how do I use my PCEP protocol and the mechanisms that we have built to satisfy the ACTN and the network slicing use cases? If everybody has state, you have a parent PCE up top, which is also stateful, and then you have your child stateful PCEs. How do they cooperate with each other? How do they tell information to each other? How does the path computation happens? And PCEP already has the right building blocks because we were anyway doing this. And using this part, we are now able to also satisfy some of the requirements of stateful HPC. Now, what is happening is we are kind of competing with YANG models in this space, because these interfaces between the controller using a netconf and the restconf interfaces and the traffic engineering YANG models, those are also getting more and more popular. Initially, we had a little bit of advantage. We used to claim that, look, we are a control plane protocol, and we have our encoding is all binary. If you start putting things in JSON and XML, things are going to be more complicated. The topologies are large. Reading all that information in those protocols is they are management lane protocol. You want immediate information in optical layer. This thing is happening. This thing I want to encode it using binary. PCEP has allowed it, but now even in the YANG world, they are exploring a new binary representation. So that also work is happening in the this thing. So this debate is still going. Let's see where we go with that. So in IETF, sometimes that happens. There are multiple solutions to the same problem, and we'll see what gets actually deployed in the network. Okay, I have 4 more minutes. Okay, so what is the role of PCE in the network slicing part? Stateful HPC is our pure base on which everything else is built. I talked about the association, that comes into play. PCEP-LS, maybe, still a question mark around it. Inter-PCE synchronization, of course, if you use PCE at different layers, we need to synchronize our databases and make sure everything is in order. That's where the inter-PCE synchronization is important. And then a way we stitch paths when you have multiple domains. That will come into play. So all of this combined, different pieces of the PCEP extensions can be used to achieve ACTN. And the next set of work that the PCE working group, basically, as you know, IETF is completely volunteer driven. Volunteer comes and present what they are currently working on, try to find cooperation and see if other people are interested in this idea, talk to the service providers that would you deploy this? What are the operational concerns? So there is no set agenda. Of course, we have a charter, and we go by the charter. Charter defines the relation, what this working group is currently working on. But most of the new work that comes in is completely volunteer driven. And if I go back and look at what the working group at each IETF meeting has been discussing, the segment routing extensions have always been the key part in the PCE working group. So I just wanted to go over that. And there are some people that I know who are working on segment routing, so that's why I wanted to add this slide and see what the work that PCE is doing in the segment routing space. So again, here we are competing a little bit with BGP, and everybody has their favorite protocol sometimes, and most of the things that you see on this slide, there is a BGP version of doing the same thing. And some people like BGP, some people like PCEP, OSPF, ISAS, IETF has this way of solving the same problem by multiple ways, which is pretty good. So what is it? SR policy, a way to define what is the characteristics of my SR path, and the container that they have in the Spring is basically what is called an SR policy. So how in PCEP I group multiple candidate paths or SR paths into one policy, that's what the SR policy is. And since in segment routing you don't have the RSVPT hop by hop signaling, you still need to do OAM, and you still need to have accounting of how much traffic is flowing from on one particular SR path. And the way to do that is, and this once we have earlier when we had RSVPT, it was pretty simple, but with SR we needed to still do that. So path segment is one way that the Spring working group has worked on, and then the same extension is happening in PCEP, that how do we assign path segments and have an identifier for a particular SR path, which is right there in the packet itself. And if I look for this particular path segment, I can do some accounting, can do some association, do bidirectional, all that stuff. P2MP, entropy, interdomains, a lot of things are happening. None of this is currently even a working group document. So these are all new work that's coming into the PCE working group. And I think my last slide, what else? Where can path computation play a key role? So some of the new networks that the IETF is working on, it's coming out. So DetNet is definitely something where PC can play a role. It's a new work. They already have a first few, I think, RFCs ready to publish, and at least they have nailed down what their characteristics are. They are nailing down what their data plane is. They have not reached the control plane place. And once they come into the control plane, then the debate will start, what is the right control plane, and if it is something like RSVPT, segment routing, something, then of course PCE will play a key role in computing the paths. People have experimented of using PCE in IoT. I have not really seen much in the IETF. There was initially a lot more discussion in Sixtish and other places, but nothing got materialized. But this is still a place where there is a scope. We have NFP, virtualizing the PCE itself, 5G network slicing, that we kind of discussed and covered quite a bit. A lot of work can happen even in the optical world, where FlexGrid is something which is the new work that's going on. There are other data planes like SRv6, here, native IP, so using of PCE. These discussions are already ongoing. There are already not working group drafts, but individual drafts in these areas, so here SRv6 and native IP as well. But not just from the standardization point of view, what are the set of things from the innovation, what you can do if you have a PCE. That's something that we have been, not at the IETF, but within our company, we have been experimenting for a long time. What kind of new algorithms that we can come up with, how we can compute path much better, how we can increase the optimization of the network, how we can help the service provider to use underutilized resources in its network. And these days, because of the telemetry part as well, what kind of enhancement will we do with PCE if I have more real-time data, and how do I scale that? Because the scaling part is the most important thing, that how do I scale the real-time information that might be coming from the network into my path computation algorithms, so that I can actually come up with something which is useful and timely. So those are the two key constraints when we think of applying any type of telemetry and AI information. That we want is to be useful, that yes, it actually has some impact, and it can scale. So those are the couple of other things that we, in this space, that is still open questions and being discussed. And I'm over my time. Any questions, please? Pretty good. So if you are interested in this thing, please join the working group. The working group is called PCE. Mailing list is easy. Let's continue with the conversation. Thank you.
That's absolutely amazing. You know, the architecture and topology and the design and all this stuff is just incredible. I was just thinking to myself how to use that in other domains. You guys have just done a tremendous job.